Hello class. Today let's go over a few problems from section 2.1. Let's jump into the exercise here. Number A. The domain are the first component of the order pair. So the domain here would be Eva, Ramsey, Carla, Sydney, and Natalie. And the range is the second component of the order pair. So 70, 78, 67, 85. 78 is already there, so we do not have to repeat. Now for number B, the domain, the first component of the order pair, 0, 10, 20, 30, 40. The second component of the order pair, outputs or range, 9.1, 6.7, 10.7, 13.2, and 21.2. Now, on the exercise number 2, we have to decide whether the relation is a function or not. Now, let's see here. Input is 1, output is 2, input is 3, output is 4, input is 5, output is 6, input is 5, output is 8. 5 has 2 outputs. So, it is not a function. But if we see the second relation, 1 has output 2, 3 has 4, 6 has 5, 8 has 5. None of the input has 2 different outputs or more. That's why it is a function. Now, if we have the equation given, then how to find or how to decide whether a given equation represents function or not? Because here y is the output, let's solve for y. Subtract 2x from both sides. We got y equals to negative 2x plus 6. For every value of x, we will get, for every value of x, that means input, we get unique output. For that reason, is a function. Now for the equation number 2, again, here the output is y. So let's solve for y. Subtract x squared from both sides. Cancel out. Y squared equals to 1 minus x squared. If we take the square root on both sides, we got y equals to square root and square cancel out, plus minus square root over 1 minus x squared. Did you notice here we do have plus minus option for y? That means if we plug one value of x, we may end up with 2 values of y. So for one input, we get 2 output. That's why it is not a function. For example, put x equals to 0. Then we will get y equals 2 plus minus square root over 1. We got plus minus 1. For one input, 0, we got 2 output plus minus 1. That's why is not a function. Now here, in this exercise, we will use vertical line test to identify whether graph is a function of x or not. Let's do the vertical line test. If we draw a bunch of vertical lines, None of the vertical lines will meet the graph at more than one point. That's why is a function. Now here, same story. If we draw a bunch of vertical lines, none of the lines will meet the graph at more than 1 point. That's why this is also a function. Now here, if you draw a bunch of vertical lines, did we see few vertical lines meets the graph at more than 1 point? For example, this point and that point. That's why not a function, because there are few vertical lines meets the graph at more than 1 point in the graph. And similar story here, there are few vertical lines meets the graph at more than 1 point. That's why this graph is not the graph of the function. Now here in exercise number 5, function is given f of x, meaning is if the input is x, output is x squared minus 2x plus 7. So f of negative 5, that means we replace x by negative 5. Negative 5 squared minus 2 times we replace x by negative 5 plus 7. This equals 25. Negative times negative is positive, plus 10 plus 7, so it is 42. That's how we find the output. Fx plus 4, so technically we replace x by x plus 4 because here the input is x plus 4. So x replaced by x plus 4. X plus 4 is squared minus 2 times x plus 4 plus 7. Now let's do the FOIL. For the first one, x plus 4 times x plus 4, that is the meaning. If you distribute negative 2, that will be negative 2x minus 8 plus 7. If you do the FOIL on the first part, it is x squared plus 8x plus 16 minus 2x minus 1. Let's combine like terms. It is x squared plus 6x plus 15. That is the final answer. In number C, we replace x by negative x. That means negative x squared minus 2 times negative x plus 7. Negative x squared and positive x squared, they are the same. So it is x squared. Negative times negative is positive. 2x plus 7. That's how we evaluate a given function at negative x. Now here, in problem number 6, we have to find a domain. Domain is how much it is extending along x-axis. Let's see. Here, so it is extending this much along x-axis. So this, the left hand point is not included. That's why it's starting at 1, and 4 is extending all the way to 4, but it is included. That's why we have to put the bracket. So that's how we find the domain. Now range is the output. Output means the height. So minimum height starting at here and extending all the way to here. So the range, what is the minimum height of the function? Again, starting at 1, but it is not included. That's why parenthesis. The maximum height of the graph is 7, but it is included. That's why it is all the way to 7. Because domain is all the x values, and the range is all the y values. Now here, the domain, it is extending this. So starting at negative 8, it is included. That's why close bracket. It's going all the way to infinity. Infinity is not the real number. That's why we put the parentheses. Now the range. What is the minimum height of the graph? Minimum height of the graph is again this. So the 0, it is included. That's why we want to put the bracket. The height is going all the way to up. It's extending. It's going up. That's why it is going all the way to infinity. That's how we find domain and range. Now for this graph, let's see how far it is extending along x-axis from this point here and from this point all the way here. So the domain, it is starting at -4. It is included. That's why close parenthesis. And it is going all the way to 5. 5 is also included because there is a solid dot included. Here you might get confused on this point. It seems 3 is not included, but with this dot, 3 is included. That's why we do not have to worry that much. Now the range. The minimum height of the graph, -2. It is included. It's going all the way to this point, and that point is 3. But 3 is not included. That's why we put the open parenthesis. And here, there is a gap. There is a gap here. So union, we have to take care of another height also. In another piece, minimum height is 4, included. Going all the way to 5, that is also included. That's how we find the range.